Hello, everyone. Welcome to our tutorial at SLAS 2025 on event-driven bioinformatics with Nextflow on the Seqera platform. My name is Ken Brewer. I'm a senior developer advocate at Seqera and am part of our community team. And I'm joined today by Edmund Miller, who's a bioinformatics engineer who joined our team just recently. So thank you so much for coming, everyone. We're super excited to present this tutorial on how to create event-driven bioinformatics workflows. So to begin with, I'd like to talk about kind of what is event-driven bioinformatics? Like what do I mean when we say we want our bioinformatics to be event-driven? So I think the best way to explain that is to contrast it with human-driven bioinformatics. And if you think about the general flow of data within a lab or a scientific organization, the core flow, in my view, comes down to transfers of information from the wet lab, where the experiments are done, to the dry lab, where some sort of computational analysis is performed, and then to the analysts and leadership who look at the processed results of the experiments and then decide kind of what are the next steps that need to be done. And of course, all of these arrows are actually, in reality, somewhat bidirectional. There's communication that happens on all sides, but I think this maps to the overall flow of the way a lot of information and decisions happens within labs. And in human-driven bioinformatics, people are the ones who are performing the data and instruction handoffs, largely with ad hoc processes. And with a whole suite of different software tools, here I've showed the Microsoft flavor of these processes, and I'm sure this will feel familiar to many of you, where perhaps the raw data comes out of the wet lab and then instantly gets copied over into an Excel spreadsheet, and that's the thing that makes its way to the dry lab, perhaps via being uploaded to OneDrive. The dry lab does its computation, which may involve some ad hoc processes themselves if they're running multiple command line tools over multiple steps. And finally, typically prepare something like PowerPoint slides and images that go to leadership, who then put together a report for like, what are the next things that they want to work on in terms of priorities for the wet lab. Now, if we want to convert this human-driven process into an event-driven process, there are some open source and commercial tools from Seqera that will be incredibly useful in making this far more reproducible and scalable. And here I've mapped out some of the core ones that we can replace with event-driven processes. Our dry lab processes that can, these complex scientific workflows with dozens of steps, we could instead replace with a Nextflow pipeline that handles the entire computation from beginning to end and does so with software containers that ensure reproducibility and also having it set up on infrastructure to scale to whatever size is needed. Instead of producing our images and reports through ad hoc processes, we can use a tool like MultiQC, which is another Seqera open source tool to generate these automatically and have them available. And all of this whole process orchestrated by Seqera in Seqera Platform. So I want to talk a little bit more detail about Nextflow and Seqera Platform for those of you who aren't familiar with these technologies. Nextflow is an open source software and programming language. The intent is to bring sort of modern software development tools to bioinformatics. And it works by connecting to your code repositories, working with software containers to ensure reproducibility, and then once the logic of your pipeline is written once, that same pipeline can be deployed to a wide range of different compute environments, from Slurm clusters to Google Cloud to AWS. And all of this is done in a way to ensure reproducibility, easy integration of a wide range of software tools, and it includes both like a CLI, primarily includes a CLI for for running these pipelines. Now, Seqera Platform was developed by the original creators of Nextflow, who created a company around providing a one-stop shop or a single platform for the entire scientific data analysis lifecycle. And this brings together Nextflow, MultiQC, Wave, which helps provision software containers, and Fusion, which is a high-performance file system for working with data in the cloud. And Seqera Platform brings your compute, your code, your data into a single user-friendly interface, along with a full suite of API endpoints and automations that can be used to make your science far more scalable than you can on your own. So today in this tutorial, we're going to be presenting a solution that can automate this whole process. And there are 6 core steps that we're going to be automating. And we're going to be presenting an example from genomics, but these 6 steps, I think, are common to a wide range of scientific processes that you're looking to automate. The first one of those is uploading raw data. So the data gets generated somewhere on an instrument that's connected to a server, and we need to copy that data from the instrument up into our cloud account, like an S3 bucket. Second step is fetching metadata. So a lot of times we need information from just the run ID about what kind of data is this. And so we'll be demoing an example of how you can incorporate fetching metadata about your data as part of this automation. The next thing is based off of the data and the metadata triggering the workflow. And here we're going to be triggering a Nextflow workflow, and we're going to be triggering it within a Seqera Platform. And Seqera Platform is also the thing that is going to help us monitor and log our run to make sure that everything goes to completion. Next, the 5th step is generating reports. We're going to show how you can look through automated reports that get generated by a Nextflow pipeline and have that be the thing that your scientists can consume and help make decisions on. And finally, we're going to showcase how you can use a tool called Seqera Data Studios to set up an environment for people to do exploratory follow-on analysis, because this is science that is often always going to be a component, even when you are automating as many of these things as you can. So in terms of the components going into the solution that we're going to demo, there are 3 core pieces. Nextflow and Seqera Platform I've already discussed. The last piece that we're going to be including in our tutorial solution is Temporal, which is another open source engine for durable execution of tasks. And Temporal really shines when you are executing smaller tasks that rely on buggy and unreliable servers and codes. And so we're going to be using Temporal for the first few pieces of our workflow, where we're uploading the raw data to S3, where we're fetching the metadata, and then triggering the workflow within Seqera Platform. And after that, Seqera Platform will handle all of the rest. So I'm now going to hand things over to my colleague, Edmund, who will give the demo of our tutorial, and will also provide, before going into the solution itself, a little bit of a demo of Seqera Platform and what it offers.
Okay, thanks, Ken. Hello, everyone. I'm Edmund Miller. I've been working in the bioinformatics space for a while. Previously, I was at Element Biosciences, and we did a lot of automation there to test our sequencers. And that's kind of where I got interested in automation and using Seqera Platform on those. So first, let's kind of do a quick little tour of Seqera Platform and get everyone orientated around that. So we're just going to open up our workspaces here first. And this is just this is actually our org here first. So we've just got an org created for SLAS 2025. And within that org, we have our workspaces. And so within that, we can also have members and kin here. We can have different teams as well. You can manage outside collaborators. And you can set this up with SSO and all kinds of other good enterprise things as well. So let's dive into our workspace. This could be for a specific R&D project. This could be for various other things. It could be coming off of sequencers. You can just kind of however you want to house those. And so we kind of need to start from the back. So first, we're going to talk about some of the setup of the Seqera platform whenever you get in, because we have a BYOB policy of bring your own bucket. And then we're going to next, and then we'll dive into some other things. But first, so we need to go in and list our participants. So you can see that I'm listed as a participant in this workspace. We have DevRel, SciDev. Again, managing those permissions is important. We have different permissions levels as well, of like you could have users that just view and users that also just launch workflows from those. And then next, we also have credentials and secrets. In this workspace specifically, we just have credentials for AWS. Seqera then takes care of everything if you give the proper credentials and sets up all the compute environments for you and bucket permissions and whatnot, just from the correct auth here. And that's all listed within our documentation. And so from that, using those credentials, then we can set up the compute environments. And so here we just have our human-driven bioinformatics compute environment and nothing too fancy going on here. We just have Fusion enabled and Wave containers, Spot instances, and a couple of other things. So nothing too crazy outside of it. Some things to note is you can have different bucket permissions. You can have resource labels. So this is useful to keep track of who's responsible for this, where this project is going, and that can then map as well to AWS cost functions as well. So you can kind of monitor all of that. So that's kind of the setup of Seqera Platform is what we just went over. Now let's talk about actually launching pipelines here. And so we can create a launchpad first. And from that, then we can set up pipelines for users to add and launch. You can go in here and specify any pipeline from private Git repos or public Git repos and just allow all of like your users to set that up. So here we've set up SeqeraKit, and that is a whole genome sequencing pipeline from NF Core, which is a org that does gold standard bioinformatics pipelines, and it's a community effort. So we've set this up here, and we can launch the workflow by clicking launch. And this brings up then a form for the user. And so there's you can set up the general config, change your compute environments based on that if you want to. You can also disable a lot of these and keep it very clean and minimal for your end users. So the wet lab users can just come in, have their data come off a sequencer, and then walk right into launching the workflow very quickly with only a few toggles. So we just have our inputs and our out directories here, and like it turns S3 into a kind of a file system that you can use, and various other advanced settings, and then a nice run summary. So we're just going to go ahead and launch this with all the defaults and kick this off. So that's now submitted our workflow. I've already got one that we've ran earlier, just so we don't have to wait for the entire test workflow to run through on that. And so as you can see, we can just see all the succeeded tasks. You can see pending, submitted, running, and this is more useful when you have a long running workflow. You can see the Nextflow command that would have been ran. Within that, you can see who ran it, lots of different kind of provenance features on that. You can also see the estimated cost, memory efficiency, CPU efficiency, and that later comes into play when you can start optimizing pipelines based off of these metrics. And these are things that you may struggle to pull out in a typical bioinformatics environment on your own and spend a lot of time trying to tweak and fine tune these things, and then you don't want to touch it ever, versus with Nextflow, it's pretty easy to tune these parameters. Okay, so we've got all of that. We've kicked off a workflow manually. However, this is about automation, and so we can do a lot of things just off of the automation of various pieces in the platform. So we've created a tool within the SciDev team called SeqeraKit. And so what SeqeraKit is a wrapper around the API of Seqera. So this is our API reference. As you can see, it has all of your typical API stuff where you can, clip things and just you can tune them however you want and call it programmatically and spin up these resources, spin stuff down, etc. But then we also want to be able to declare some of this stuff and do a little bit more GitOps of the workflows on these. And so we have SeqeraKit, which is a YAML configuration and a CLI tool to run those. So from here, we have on the right, this is our compute environment for our human-driven bioinformatics and specified in the Git repo that we'll share later with you. And so from this, you can see all the configuration options. And so we can set that, check it into a Git repo, reproduce it later, or come back to the project on those. So these are really handy when you're doing one-off experiments, and you can just kind of pull each of the pieces out. Let's see. So the next piece that I'd like to show in SeqeraKit here is the actions on this. And this is a piece that we haven't talked about in automation yet. So that kind of encompasses all of SeqeraKit, but now we have this new piece called actions. And so that allows you to launch a workflow programmatically from each of these. So if we go back to platform and get rid of the SeqeraKit code, you can see there's an actions tab. And so this one is a lot of the heavy automation. So the API also has a launch endpoint. You can hit all of those, but this is a very quick way to get started with automating workflows. And so you can just add an action, fill out the form here of like what pipeline you want to launch, the revision number, so you can lock that down. And then from there, you can take the like work directories and whatnot, and then you'll end up with this beautiful action. And so this is just an example to hit it with a curl command. We're going to do a little bit more than that today on that. So now we'll jump actually into the demo part of that. So that was an action. Now we're going to actually hit that with a temporal launch there. And so let me pull over a terminal. So we've got a workflow trigger here in the repo, and then our temporal dashboard over here going. And so this is one that's already ran previously. If we go back, we should have one that's running. So you can see that this is just checking every 10 seconds to see if it has any unprocessed files. This is just kind of simulating a sequencer, which will typically have like a run finished file that gets uploaded on those. And then you'll know that the sequencing run is finished, and then you can kick off some automation downstream from that. So using temporal here, we can trigger the workflow. This is just going to download some fast queues into a local directory here on my laptop. And then from that, it's also going to create a sequenced file. And so you can see that kicked off things over here in the temporal world. And so we've downloaded the CSV, we've uploaded to S3 now, and then now we're triggering the workflow here. And so as we go through that, you'll see that it's attempting it, and it's just waiting for a response from the platform. It just takes a minute to talk to all the various AWS pieces. And you can see that our temporal workflow has completed. And so from that has then kicked off our Nextflow workflow over here. So that was our demonstration of temporal kicking off Nextflow from those. And I've added a little tag down here to show that this was the source of, this was from automation here. And then this one was from the Launchpad was the difference. So as you can see, our job that we kicked off earlier, it's now running and submitting. So let's go back to runs on this, and let's take a look at this output here from the run that we've already completed. So you can see that we have different reports as well baked into each of the runs that you can configure. And so we can open the multi-QC, and this is using Data Explorer in the background of that. And we can talk a little bit more about that in the future as well. But so you can go through and see all the various results. And this is just a test run, so ignore all the failures. And you can easily download and pull those in from each of them. So you can imagine that your typical reports that you have in your bioinformatics workflows currently, you can just pull those out and put them into Platform. And it's a nice, easy interface for then your decision makers to go in and pull the data from that and not just wait on the bioinformaticians to go and hand them the data and send it to them in an email. So that was just a quick overview of the reports and how that can be automated and pulled in. Now let's talk about Data Explorer really quick. So this is a really amazing feature. If you've ever worked with S3, you know that it's really difficult to treat it like a normal file system and just kind of view it. We built out Data Explorer, which allows you to just browse these remote repositories. So you can see here's all the different buckets that we have access to within this workspace. And then you can go into our bucket here for SLAS 2025, and you can see our inputs. And these are the files that we uploaded in our temporal workflow. And then you can see the results coming off from the workflow here. So our multi-QC reports, and can download these files as well. So this is pretty useful from the standpoint of the user. And then you can also go in here as well to the actual like runs, and you can check out the different work directories and get into those. And that makes debugging really easy for your bioinformaticians on this. And you can see in Data Explorer here that we can actually go in, pull the files, figure out what's happening in each individual step, which can kind of be difficult in the cloud where you're not working with like a computer that's just constantly on. Sometimes it's flipping off. Okay, so that was a little bit about Data Explorer. And then lastly, let's touch on Data Studios here. So this is a new feature that we've built. And so everyone loves a interactive environment, and we do all of this automation so then we can actually do some analysis downstream on these. And so from that, we've got a couple different examples going here, but we're just going to talk about the X one. So we have Jupyter notebooks, we have our studios. From those, we can also create custom environments just from a container if anyone has any interesting ideas. So creating one's pretty easy. You can just click add, and then you can pick the data that you want to mount as well, and just go in here and add that and set up the config, install various conda packages that you might want, go through any of those. You can also just set up VS Code as well. I don't think I mentioned that earlier. So that's all great. You can also request GPUs if you have GPUs in your compute environment, if that's of interest to you. So I've already got a tab open here with this one. And so this is just a X environment here that we have loaded up with IGV genome browser. And so this is just a terminal interface, and you're just logged into this EC2 instance here. And I think that's pretty cool and powerful for users to use, because instead of working back and forth between your laptop and various other things. And so while IGV may not be very difficult to compute wise, it can be difficult to set up, and you can just kind of pull those in from that. And I think we can load some files here from that. So if we go into here, and so you see this is just like a normal file interface from those. And so we've got a couple of files loaded up, and then I think we can zoom in here on those. Maybe I'm on the wrong chromosome. So this is just a test data set. There may not be much to glean from it. It's a pretty small piece, kind of hunting for a needle in a haystack there. There we go. And so you can just go in an interactive environment and actually start to do some analyses and make some decisions off of that data. So that was Data Studios. I think that kind of covers all of the pieces of Seqera Platform and launching the automation with that. So thank you all.
So thank you for that that demo, Edmund. just to kind of recap what we worked on. Um, we have all of the resources that we demoed, like code for setting this all up in your own environment, and the repo Seqera Lab / Hello Automation. The core components that you can look at there are here in this platform directory. We have all of the YAMLs, SeqeraKit YAMLs for setting up all of the infrastructure in Seqera Platform. And here in the source directory, we have a folder that has all of the temporal workflows that are going to be used for each of those individuals' initial steps, from monitoring the sequencer folder, uploading to S3, fetching metadata, and then triggering the workflow in Seqera Platform. So in terms of the overall solution that we covered, we did hit all 6 of these steps. And of course, our code itself will not be the end solution, but we wanted to put it together as like a very simple example of how you can do an end-to-end automated process using the combination of these tools, Temporal, Seqera Platform, and Nextflow. So now we're happy to take any questions. And thank you so much for coming.